Here we have the function f of x equal to 0.5 times x to the fourth plus x plus 4. And we want to find the area of the region bounded by the graph and the x-axis from 0 to 2. And so first, to get an approximated value for the area of the shaded region, we'll fill this up with a few rectangles and then find the areas of the rectangles and then add them up, and that will give us an approximated value for the area of the shaded region. And then we'll fill it up with an infinite number of rectangles to get the exact area. And so here we fill the shaded region with 5 rectangles. And what we want to do is find the area of each rectangle and then add the areas together, and that will give us an approximated value for the shaded area in the shaded region. And so the function we're dealing with is 0.5x to the fourth plus x plus 4. So let's take a look in the first rectangle right here. This is x of 0, this is x of 1, x of 2, x of 3, x of 4, and x of 5. And so in this case, x of 0 is 0, x of 1 is 0.4. Since we're going from 0 to 2, and we're dividing it by 5, and so 2 divided by 5 is 0.4. And so the width of each rectangle is 0.4. And so the width of the first rectangle is 0.4. And then to get the height of the first rectangle, we use what's called the right endpoint method. And so this is 0, this is 0.4, and we will use the 0.4 to get the height. So this is 0.4, then the corresponding y is 4.4128. So f, and so plugged in 0.4 and 0.4 here, then we get 4.4128. And so this point right here is the point 0.4 for the x and 4.4128 for the y. And therefore the height of the first rectangle is 4.4128. And the area would be 1.76512. And so that's the area of the first rectangle. And here's the area of the second rectangle. This is 0.4 and this is 0.8. And again, we're using the right endpoint method, and therefore we will use the 0.8 to find the height. Now if we were to use the left endpoint method, then we would have used the 0.4 to find the height for the second rectangle. But since we're doing the right endpoint method, we will use the 0.8 to find the height for the second rectangle. And so the height here would be x 0.8, and then the y is 5.0048. And so this point right here, this is 0.8 for x and 5.0048 for the y. And therefore the height of this second rectangle is 5.0048, which is right here. And then so the area for the second rectangle is 2.00192. And then let's do one more. For the third rectangle, this is 0.8, which is x of 2, and this is 1.2, which is x of 3. So again, this is x of 0, x of 1, x of 2, x of 3, x of 4, x of 5. And so the height, again, we will use the 1.2. This is 0.8, this is 1.2, and we use the 1.2 to find the height. So next is 1.2, y is 6.2368. And therefore the height of the third rectangle, this point right here, is 1.2 for the x and 6.2368 for the y. And therefore the height of the third rectangle is 6.2368, and the area is 2.49472. And this is the area of the fourth rectangle, and this is the area of the fifth rectangle. And then if we look at our rectangles again, notice that the rectangles that we're using, they cover the outside of the bounded of the shaded region, and therefore when we add the areas of the 5 rectangles together, we get 15.41. And so this number right here, 15.41, will be much higher than the area of the shaded region. But as we add more rectangles, we will get a better approximation. So for 5 rectangles, we got a sum of areas of 15.41. And so we say that the area of the shaded region is approximately 15.41, even though this is not a good approximation because the rectangles, they are outside of the shaded region. So well, let's add more rectangles now, and so we can get the better approximation. And so here's 10 rectangles, and the sum of the area is 14.25. And here's 15 rectangles, 20 rectangles. Is 100 rectangles, and we got about 13.3. So let's do one more. Let's fill it up with 1,000 rectangles. And so for 1,000 rectangles, we got 13.21 for the area of the shaded region. And then now let's go fill it up with an infinite number of rectangles and see what we get for the exact answer of the shaded region. And first, let's find the areas of n number of rectangles. And so delta x, delta x represent the width of each rectangle. And the width of each rectangle can be found by doing b minus a over n. In this case, b is 2, a is 0, so we get 2 over n. 2 over n will be the width of each rectangle. Initially, we fill it up with 5 rectangles, then n would be 5, and the width of each rectangle would be 2 divided by 5, which is 0.4. But here we want it to be just n. The width of the rectangles, and then now let's write the x sub i's in terms of delta x. This is x sub 0, which is 0. This is x sub 1, x sub 2, x sub 3, x sub 4, x sub 5, if we have 5 rectangles. And so look at x sub 1. X sub 1 is just going to be x sub 0 plus 1 width. So it would be 1, but x sub 0 is 0. So it would be 0 plus 1 delta x, because delta x is the width of each rectangle. And then x sub 2, which is right here, it'd be x sub 0 plus 2 widths. And so it'd be 0 plus 2 delta x. And then x sub 3, it'd be x sub 0 plus 3 widths. So it'd be 0 plus 3 delta x. And then x sub 4 would be x sub 0 plus 4 widths. So it would be 0 plus 4 delta x, which is 4 delta x. And so in general, x sub I is just I times delta x. And so that's what the x sub i's are. And so now let's find the height of each rectangle. The function we have is 0.5x to the fourth plus x plus 4. And so f of x sub I, then in the place of x, we just have x sub I. We just found that x sub I is I times delta x, And so right here in the place of x sub I, we have I times delta x, I times delta x. But delta x is 2 over n. That's the width of each rectangle. So it'll be 2 over n. Delta x is the width of each rectangle, and so it's 2 over n. And so this becomes I to the fourth, and then 2 to the fourth is 16. 16 times 0.5 is 8. And then we have n to the fourth is n to the fourth. So that's how we end up with the a over n to the fourth times I to the fourth. And this will be 2 over n times I, and then plus 4. And so this is the height of the ith rectangle in terms of n. So this is height of ith rectangle. And so, for example, if we want what is the height of the first rectangle, in this case n is 5, then here we will put a 5, and then here we put a 1 for the first rectangle, and put a 5 here and then a 1 here, and then calculate this, and it will give us the height of the first rectangle, and so on. And so far we have found that the width of each rectangle is 2 over n, x sub I is I times delta x, and the height of the ith rectangle is 8 over n to the fourth times I to the fourth plus 2 over n times I, and then plus 4. So this is the height of the ith rectangle. And now let's get the area of the ith rectangle. So the area be the height and then times the width. So this is the height and this is the width. And so the height is this, and then the width is 2 over n. 2 over n. So this is height of the ith rectangle. This is the width of the ith rectangle. Since all widths are the same, and so that's why there's no I here. And then multiply this out, we get 16 over n to the fifth, dividing by times I to the fourth, plus 4 over n squared times I, and then plus a over n. So this is the area of the ith rectangle. And now we want areas of n number of rectangles. And so we'll do summation from 1 to n. So this is the sum of areas of n number of rectangles. But f of x sub I times delta x is be replaced with this, because this is f of x sub I times delta x. Is this expression right here. And this is summation of a sum of sum, and therefore we can write it as sums of summations. And then this is 16 over n to the fifth, which is a constant, so we can move it and place it in front of the summation notation. This is 4 over n squared, and this is a constant because the summation is with respect to I, and there's no I here. And for summation of a constant, then it'd be just the constant times n. And therefore this summation right here be just a over n times n, because there's no I here, so think of it as a constant. So it'll be the constant a over n, and then times n. And this is either the summation of I to the fourth and summation of I. So we need two formulas for this one and this one. Summation of I, which is 1 plus 2 plus all the way up to n, is n squared divided by 2 plus n over 2. And then summation of I to the fourth is this formula right here. And so now we have 16 over n to the fifth, and then summation of I to the fourth, we'll replace it with this. And then summation of I, we'll replace it with n squared over 2 plus n over 2. And as mentioned earlier, this is summation of the constant a over n, because the summation is over I, or with respect to I. And there's no I here, so think of this as constant. So the a over n times n. And then now multiply everything out. When we multiply this out, this is what the result is. And then when we multiply this out, we get 2 over 2 over n plus 2 over n. And then the last term is just 8. And so this is the sum of n of areas of n rectangle, n number of rectangles. And so if n is 5, then this will be the sum of areas of 5 rectangles. If n is 100, then this will be the sum of areas of 100 rectangles, and so on. But since we want the exact answer, then we need to allow n to run to infinity. And so we want an infinite number of rectangles. And this is how we write sum of an infinite number of rectangles. Let n run to infinity, and then the summation right here. And so we look back right here, and now we're allowing n to run to infinity. And so as n runs to infinity, then we get 16 over 5. This will go to 0, because 16 divided by infinity will be 0. This will go to 0, 0, and we get 2. And this will go to 0, and we get 8. And then add these numbers together, we get 13 1/5, or 13.2. And so the exact area of the shaded region is 13.2. And now look back at our graph, our shaded region. We fill it up with 1,000 rectangles, and we got 13.21. The exact answer is 13.2. And so as n, the number of rectangles or number of subintervals, gets larger and larger and larger, this number right here will approach 13.2. And that's the exact area of the shaded region, 13.2.